Open December 2021, question 7A. So December, so we have two Decembers. One is the pilot paper, the other one is the little paper. So we are not doing the pilot paper, we are doing the little paper. A random sample of 15 employees of a call center was taken, and each employee took a competency test. The mean of the score achieved by these employees was 56.3%. Mean is the average, was 56.3%, with a standard deviation of 7.1. Standard deviation was 7.1, and was a sample of 15 employees. So N is 15. The result of this test have been found to be normally distributed in the past. Required. Construct a 95% confidence interval for the mean of test score of the call center employees. Confidence interval. So for confidence interval, say that is X bar plus or minus. Now, in this case, we use a T because the sample size is less than 15. But in this case, we won't use T. We use Z. Why? There is a reason. Can we read the last sentence? The result of this test have been found to be normally distributed. When you talk about the normal distribution, we use Z. Now, in this case, even if the sample size was less than 30, this was not population size, this was a sample size. So that means have been done from a population of greater than 30. That's why I told that it's normally distributed. So we apply the concept of normal distribution. So instead of T, we'll use Z, standard deviation, square root of N. But in case they have not stated about the normal distribution, this one could be T. So X bar, so you're testing at 95% confidence interval. If you want to be 95% confidence, that means the significance level will be 5%. X bar, in this case, the average is 56.3 plus or minus. Z at 5%. Remember, for confidence interval, we say that we always use a two-tailed test. If it's a two-tailed test, Z will always be 1.96 times standard deviation. Our standard deviation is 7.1 over square root of N, which is 15. So 56.3 plus or minus. Now give me the margin of error. The 3.55. 59. So therefore, give me the upper control limit and lower control limit. So for the upper control limit, you add. For the lower control limit, you minus. 59.89. 52.7. 0.71. So therefore, the confidence interval will lie between 52.71 and 59.8. December 2022, question 4A. The production manager of Medtex Limited, a manufacturer of machine, is investigating a claim by customer about machine A and machine B that it manufactures. So machine A, machine B. So that means this is a case of a 2 min samples. The claim is that machine A has a longer useful life than machine B. So we have machine A and we have machine B. A sample of 60 machine A's taken. So N for A was 60. A sample of 60 machine A's taken from the market reveal that the machine has a mean useful life of 28,000, mean life 28,000 hours with a standard deviation of 900 hours. Standard deviation is 900. A sample of 80 machine B's, so BN is 80, has a mean useful life of 30 hours, so 30,000 hours with a standard deviation of 1,000. Standard deviation is 1,000. Required. Advise the production manager of Medtex Limited if there is a significant difference in the useful life of machine. Use a significance level of 5%. So you follow the hypothesis testing. Step number 1, null hypothesis. Mean of 1 is equal to mean of 2. Alternate hypothesis, mean of 1 is not equal to mean of 2. Significance level is at 5%. That step, you come up with a Z or T test. Now, since our sample size is greater than 30, so therefore use a Z test. So we get Z calculated. For 2 samples, it's X bar 1 minus X bar 2 over square root of standard deviation of 1 square, N of 1, standard deviation of 2 square, N of 2. So it will be X bar 1, we have is 28,000 minus X bar 2, which is 30,000. You divide by standard deviation of 1 square. So it's 900 you square to get the variance over N1. N was 60 plus standard deviation of 2, which is 1,000. You square to get the variance over N2. It's N we have, it's 80. With that. Negative 12.40. So now you compare Z calculated against Z critical. Now, Z critical, you come up with a decision rule. And we say that when inequality of null hypothesis is not equal to, we use a two-tail test. So here we accept the null hypothesis. Here we reject null hypothesis. Here you reject null hypothesis. And this one is said it's alpha over 2. So if you're using 5% and it's a two-tail test, Z automatically will be 1.96. Negative 1.96. 1.96, but positive. Then you ask yourself, now Z calculated is negative 12.4. Does it fall in between the acceptance region or rejection region? Rejection. So you reject the null hypothesis at 5% significance level. But this is how we need to comment. You see, in this case, we are conducting the test where there's a significance difference in the mean life length between machine A and machine B. If we reject the null hypothesis, that means we accept alternate hypothesis. What does it mean? That means the mean life of machine A and machine B are not equal. So therefore, there is a significance difference. So if they are not equal, that means there is a significance difference between machine A and machine B economic life. Economic life. Good. So you can copy. At A, in the context of hypothesis testing, distinguish between type 1 error and type 2 error. You see that type 1 error is an error made when you accept a wrong or a false hypothesis. Or you can do this null hypothesis. The claim can either be true or false. Then you can either accept or reject. You can either accept or reject. Now, when you reject a true hypothesis, now you are making type 1 error. And then if you accept a false hypothesis, that's type 2 error. Therefore, type 1 error is an error made when you reject a true hypothesis, and type 2 error is an error made when you accept a false hypothesis. And you get your 4 marks. Number B, the cells before and after. Before and after. Therefore, that one is a two-mean test. Before, after. The sales before and after promotional campaign of 10 different regions of a certain commodity were recorded as follows. So we have region 1 to 10. So that means N is 10, N is 10. So it's a small sample. For small sample, we use t-test, not z-test. I've seen there's a student who has asked why the first question we used a t-test. I mean z-test instead of t-test. And I think I explained very well. I explained very well that we see that. For the first question we did today, or this session, you are told that it was taken from a sample of 15, but they assumed to you to have normal distribution. A normal distribution, that one we use Z. So we have the sales before promotional campaign, shillings in million, also the sales after promotional campaign. Required. Using 5% level of significance, determine whether promotional campaign was successful or not. So for us to conduct that one is a two-mean test. So you need average, that's X bar. You also need standard deviation. So how do you get your 16 marks? I showed you on how to use a calculator to determine the mean and standard deviation. Now, for example, before the campaign, now can you add the total? Add the total sales? Add the total sales. Then you divide by 10. That's how you get the mean or the average. And how much is the average? 41, eh? Now do the same for after. Add the total. You add the total. Sorry? This one. 40.7. Now let's get the standard deviation. Now to get the standard deviation, I give you the formula that to get the standard deviation, you take X minus X bar square. In this case, we don't have probability. So you add all of them over N minus 1. In case you don't have probabilities N minus 1, then you get the square root. Or alternatively, you use a calculator. Now let's use a calculator. First of all, you clear your calculator. Shift mod 3, you press equals twice. That's how you create. Shift mod 3 equals. Then how do you insert the formula for standard deviation? So you press mod, then SD. SD number 2. Good. So now once we insert the formula, how do you insert the data? Now let's start with the before. For before, the first sales for the first region was 53. You press 53, M plus 28, M plus that one, M plus. Can you insert all that data until you get N is equals to 10? until you get n is equals to 10. So if n is equals to 10, press on. So shift number 2. Can you see X bar? X bar is number. Press 1 equals. Do you get 41? Good. Press shift again. Number 1 again. Then give me standard deviation. So that for standard deviation, you press 3. Use the one for 3. 3 equals. How much is the standard deviation? Sorry? 12.5. Now clear your calculator. Clear. Shift mode 3 equals. Shift mode 3 equals. Now, once you clear, insert the formula again. You press mode, then SD, which is number 2. Mode, then SD, which is number 2. Then from that, you insert the data. Now, after promotional, you press 58 M plus, 29 M plus. Yeah, insert all that data until you get n is equals to 10. You're getting 13.4. Yeah, so you say that if n is equals to 10, you press on. Once you press on, you press shift number 1. So to get the standard deviation, you press 3 equals. So that's I get that. And now we have to conduct. Now the question was, using 5% level of significance, therefore this is hypothesis testing, determine whether the proportional campaign was successful or not, 16 marks. So hypothesis testing. You start with the null hypothesis that mean of 1 is equal to mean of 2. That means before and after are the same. Alternate, you say that there is no significance difference, or there is significance difference. So mean of 1 is not equal to mean of 2. Significance level is at 5%. Then n is less than 30. So therefore use t-test. But the formula is the same. X bar 1, X bar 2 over square root of standard deviation of 1 square, n of 1, standard deviation of 2 square, n of 2. So X bar 1, the mean we have is 41. So we'll take 41 minus X bar 2, which is 40.7 over square root of standard deviation of 1 square, which is 12.5 square, over n of 1, n was 10, plus standard deviation of 2, 13.4 is square to get the variance, over n of 2, which is 10. So give me that. Zero point 0.05. Then you compare the T calculated against the T critical. So how do we get the T critical? Yeah, for 2 mean sample, we always use a 2-tail test. So here you reject null hypothesis. Here you reject null hypothesis, and this is alpha over 2. Here we accept null hypothesis. Now for T, you need degrees of freedom. So how do we get the degrees of freedom in case of a 2 mean? It's n of 1 minus 1 plus n of 2 minus 1. So this is 10 minus 1, you get 9, plus 10 minus 1, you get 9. 9 plus 9, you get 18. So we want T alpha over 2, where n is 18. So our significance level was 5%. Now you go to your T table where we have 0.05 or 0.025. Since if you take alpha, which is 5 divided by 2, get 2.5%. And then where degrees of freedom is 18. So you go to the T table. You look where you have, here you look at 0.05 and 0.025. Then you drop where the degrees of freedom is 18. And then you give me the t value. 2.101. So this one would be 2.101, 2.101. This is positive, this is negative. So now you compare your T calculated against T critical. Now 0.05, does it fall in between the acceptance region or rejection region? Acceptance. So comment. So accept null hypothesis at 5% significance level. What does that mean? So if you accept the null hypothesis, we are saying that mean of 1 is the same as mean of 2. What does that mean? That means the average sales before campaign and after campaign were the same. So therefore, was campaign of advertisement, was it successful? It was not successful. Because if you expect them to be successful, you expect after campaign, the sales to increase. But in this case, did not increase. So that's why they were same. So that means, now the question was, using 5% level of significance, determine whether the promotional campaign was successful or not. So the campaign was not successful. Was not successful. And this is because the average revenue or the average sales revenue before and after they are the same. That's why you have accepted the null hypothesis. If they are the same, that means there was no need to advertise then. So therefore, it was not successful. Open November 2020, question 1C. Once you are told that an accounting college has 2 classes, day class and evening. So that's a 2 mean sample. Day class and evening class. So you have the number of students, that's N. For day we have is 13. For evening, it's 15. Average test marks, that's average X bar. For this student is 45. For the evening, it's 55. Then the standard deviation for day, it's 4%. For the evening, we have it 5. Required. Determine whether there is any significant difference in the average test marks between the 2 classes at 5% level of significance. So first of all, N is small samples. So small sample, we use t-test. So null hypothesis, mean of 1 is equals to mean of 2. That means the average for the student at evening are the same. Alternate hypothesis, mean of 1 is not the same. Significance level is at 5%. T-test, X bar 1 minus X bar 2, square root of standard deviation of 1 square, N of 1, standard deviation of 1 square, sorry, of 2 square, N of 2. So X bar 1 we have is 45. X bar 2 we have is 55. And then standard deviation of 1 is 4 square to get the variance over N. N is 13 plus standard deviation of 2, which is 5. So it's 5 square over N2, which is 15. What do you get? Negative 5.87. So you compare the T calculated against the T critical. So this one should always be a two-tailed test. So here we accept a null hypothesis. Here you reject null hypothesis. Here you reject null hypothesis. So we need the degrees of freedom. In case of a two-mean test, degrees of freedom is n1 minus 1 plus n2 minus 1. So here we had 13 minus 1, you get 12, plus n2 was 15. 15 minus 1, you get 14. 13 plus 14, you get 27. Then our significance level is 5%. So it's 5 over 2, you get 2.5%. So since a two-tailed test, now you look where we have 0.025 and 0.05. Then you go where the degrees of freedom is 27. If you can't find the degrees of freedom of 27, you look at the figure close to 27. If 27 is not in your table, you use the figure close to that. 27 is there. Sorry? T is equals to? Sorry? Oh, this is 12 plus 14. Eh? This one should be 26, sorry. Hmm? 2.056. So this is 2.056. 2.056. Positive, negative. Our T calculated is negative 5.87. Now, does it fall in between the acceptance region or rejection region? Rejection. So it falls within the rejection. So that means we reject the null hypothesis at 5% significance level. What does it mean? If we reject the null hypothesis, that means we accept alternate hypothesis. Alternate, that means that the mean of 1 is not equal to mean of 2. So that means if mean of 1 and mean of 2 is not the same, that means the average pass or pass mark of day and evening student is different. Or you can just simply say that there is a significance difference between day class and evening class average, which test are we conducting? Is it average? Yeah, average test marks, eh? Average test marks. Good. Can copy? Now let's do some question on probability theory. April 2022, question 4B. Question 4B. The saving account of a certain microfinance bank have an average balance of 240,000 and a standard deviation of 60,000. The account balance is assumed to be normally distributed. Yeah, normal distribution. That's what we call a normal distribution. For normal distribution, we have X bar, then we have standard deviation. So I told that the saving account of a certain microfinance bank have an average balance of 40, so 240, and a standard deviation of 60,000. The account balance is assumed to be normally distributed. Number one, the proportion of saving account whose balance is above 275. Above 275. Now, 275 is on this side. Now, that's what we call X1, 275. Now, we want the account above 275. So, how do we get Z? Z, it's X bar. Sorry, not X bar. But X1 minus X bar over standard deviation. Now, these are normal distribution. X1 we have is 275. X bar we have is 240. Standard deviation we have is 60. So give me into 2 decimal places. .58. Now you read it from the table. Now let's go to the Z distribution table. Z distribution table. You look where you have 0.5, then 8. 0.5 and then 8. Ah, Kioko nisome. 0.15. Human left nisome. 90. So now this is a probability between 275 and 240. But this is not what we want. We don't need this probability. This is a probability of 0.2190. So, but you know that all this, it's 0.5. Now, if this is 0.5 and the probability of between 240 and 275 is 0.2190. So we want now greater than the shaded part. So therefore, to get the probability, we take 0.5 minus 0.2190 and it will get 0.280. Good. Number 2. So X bar is 240. Standard deviation we have is 60. Number 2 is the proportion of savings account whose balance lies between 190 and 260. 190 to 60. So in this case, we want in between. So shade the required region or the region of interest. So in this case, we have to compute two z's. Z is equals to x bar minus, sorry, x bar. But x1 minus x bar over standard deviation, z1, z2. 190 minus 240, standard deviation is 60. Now this one will be 260 minus 240 divided by 60. Ignore the sign. 0.83. Over 60 is a third. A third is 0.33. Then add it from the table. One? 293. 0.33. Zero point 2967. So now we want between 190 and 260. Now the first one is between 190 and 240. This one is between 260 and 240. So you just add the two. You get 0.3. 26, eh? Yeah, so that's the probability. We are done. Open September 2021, question 5B. From 5B. A recent inspection of bolts produced by certain company revealed that 16 bolts were defective out of total of 40 bolts inspected. So what's the probability of having a defective? We read again. A recent inspection of bolts produced by certain company revealed that 16 bolts were defective out of total of 40 bolts. So it's 16 of the 40. So that means the probability of a bolt being defective is 0.4. 5 bolts are picked at random and inspected. So he picked 5 of them. Required, number 1. Assuming that distribution of defective bolts follows Poisson distribution, calculate the probability that at least 3 bolts were defective. Number 1, we have to use Poisson distribution. Now, for Poisson distribution, you need to know how to get the probability. Probability is exponential raised to power negative lambda times lambda raised to power x over x factorial, where lambda is the mean or the average occurrence. Now, the probability of having a defective is 0.4. And we have picked 5 bolts. So what's the mean or the average? So 0.4, you multiply by 5. So that means the mean occurrence will be 2. Good. Then the question is, we want probability where x, assuming that the distribution of defective bolts follows Poisson distribution, calculate the probability that at least 3 bolts are defective. Now, at least 3, that means the probability where x is either 3, 4, 5, or alternatively, you take probability where x, you take 1 minus 0, 1, and 2. So you do that. So probability will be 1 minus, now these are our x's. Now let's start when x is 0. So it will be exponential raised power, lambda is 2, so it's negative 2. 2 raised power x. Now our x is 0. over 0 factorial or plus negative 2 raised power x. Now when x is 1 over 1 factorial or exponential raised power negative 2. Average does not change. Times lambda, which is 2. Now when our x is 2 raised power 2 over 2 factorial. So it will be 1 minus. Now that's do the first one, the second one, and that's do the third one. Okay. 1353. Mm, 0 point. So give me the probability. Three, two? Three. Then number 2, assuming that the distribution of defective bolts follows binomial distribution, calculate the probability that at most 3 bolts are defective, at most. So that's the probability that x at most 3 is either 0, 1, 2, but with a maximum of 3. Now, under binomial distribution, probability is equals to NC x times p raised power x times q n minus x. Now, n, in this case, we picked 5 bolts. X, we have our x's here. We need p. Now, p is the probability of defective. Probability of defective is 0.4. We need q. Q is 1 minus p. So it's 1 minus 0.4, get 0.6. So it will be NCX. So the probability will be n is 5. Now we start when x is 0. 5 combined 0 times probability 0.4 raised power x. X is 0 times q. Q is 0.6. 5 minus 0, it's 5. Or 5 combined 1 times 0.4 raised power 1 is 0.6. 5 minus 1, you get 4. Or 5 combined 2, probability is 0.4 raised power 2, 0.6. 5 minus 2, you get 3. Or 5 combined 3 times probability is 0.4 raised power 3 times q, 0.6. 5 minus 3, you get 2. So give me that. Zero point? 0.076. Sorry? And then you add? So now let's add that to probability. Good. So can copy. So let's try another illustration. December 2021, question 6C. December 2021, question 6C. Question 6C. Now, 6C, we are told that during a manufacture of a product, 0.002 of the product turns out to be defective. And the product is supplied in packet of 10. A consignment of 100 packets is produced in a certain period required. Using Poisson distribution, calculate the approximate number of packets containing Poisson distribution. You Poisson, you write the formula, exponential raised power negative lambda times lambda raised power x over x factorial. Now, do you have the key ingredient? Mostly, this is lambda, the mean. Now, how do you get the mean? Now, I took that. During a manufacture of a product, 0.02 of the product turns out to be defective. The product is supplied in packets of 10. So it's 10, 10, 10, 10. A consignment of 100,000 packets. So the consignment is at 100,000 packets. So therefore, we need to get the mean occurrence per packet. If that's probability of having a defective, and we are producing in packet of 10, so you multiply by 10. So on average, how much the mean occurrence per packet? That's what you do. You get? You get 0.02. That's our lambda. Now, required. Using Poisson distribution, calculate the approximate number of packets containing, number one, no defective. No defective is where x is equals to 0. So it will be p exponential raised power negative lambda. Now, lambda is 0.02 times lambda 0.02 raised power x. X is 0 over 0 factorial. Now, give me the probability of having no defective that packet. You get 0.98. If this is the probability of having no defective, now that's not the question. Now the question was, using Poisson distribution, calculate the approximate number of packets. So you multiply by the number of packets. We produced how many packets? 100,000. So approximately 98. Yeah, 98 packets will have no defective. And number two, one defective. So x, probability that x is equals to 1. So its probability will be e raised power negative 0.02 times lambda 0.02 raised power 1 over 1 factorial. So what do you get? Zero point 0196. So then we want the number of packets. So you multiply by 100,000. So how many packets will contain only one defective? Sorry? 1960 packets. And then number three, two defective probability where x is equals to 2. It will be a raised power negative 0.02 times 0.02 raised power 2 over 2 factorial. get 0.16196. Then you want the number of packets. You multiply by 100,000. 90? Sorry? 19.6, eh? Approximately 20 packets. Good. May 2021, question 1C. May 2021, question 1C. So to that, the registrar of Highfriar University has observed that the grade point aggregate of the university student is normally distributed. So normally distributed. It's normally distributed with a mean of 2.75. So the mean is 2.75 and a standard deviation of 0.4 required. So it's normally distributed. That's the concept used. Required, number one, the probability that a randomly selected student from the university has a grade point aggregate of between 2 and 3, between 2 and 3. So 2 is on the lower side, 3 is on the upper side. So this is x1, also this is x1. So we want the probability to be between 2 and 3. Z is equals to x1 minus x bar over standard deviation. Z1, Z2. So this one will be 2, x bar is 2.75, standard deviation is 0.4. Z2, we use x, the other x, which is 3 minus 2.75 over 0.4. I should always be into 2 decimal places. Sorry? Sorry? 1.88. But we say that for normal distribution, we ignore the negative. Eh? Negative means on the lower side, positive on the upper side. 0.63. Now we did this from the table. We did them from the table. I use the normal distribution table. .4699. 0.63. 0.257. And since what between the two, so you add. Get 0.7. 5. Good. Number 2. The lowest grade point. So this one, you don't require the probability. We need X. The lowest grade point aggregate that should be obtained by a student for him or herself to be among the top 10% student. For you to be among top 10, that means you're above average. If you're above average, so what we need is X1 here. In that, you will be top 10 student. So that means the probability is 10%. So now the question was, how much grade point should you attain for you to be among top 10? Now, among top 10, this 10%, we know that all this, the probability is 0.5. If this is 10%, that means this will be, this one will be how much? 0.4. Now, this is the probability. We don't want probability, we want Z. So how do we get Z? So how do we get Z? Now, to get Z, we need this. So what you'll do, you'll take 0.5 to get Z, it's 0.5 minus this 10, which is 0.1, and you'll get 0.4. Now, once you get this probability, what we need is Z. Remember here you are getting Z, so that you read it from the table to get the probability. Now, in this case, we have the probability. We want to work backward to get that Z. So therefore, you read this one inside the table, not from the table, but inside the table. So now go to the normal distribution table. Huku ndani utafute 0.4. And if it's not exact, you look for the figure close to 0.4. Then once you get that figure, you read the coordinates. You're getting 1.2? Yeah, so this is our Z. So we know better that if you take Z, it's x1 minus x bar over standard deviation. So what we need is this. So to get x1, we'll take x bar plus or minus Z standard deviation. But now you need to know when to add, when to raise. When it's on the upper side, we add. When there's the lower side, you minus. So you take x bar, which is 2.75 plus Z. Now our Z is 1.29 standard deviation. Standard deviation was 0.4. In case it was on the lower side, you would have taken 2.7, you minus that. This one you could have deducted. But in this case, on the upper side, we add. So what do you get? 3 point? Yeah, 2.6. That means for you to be among the top 10 students, you must attain a grade point of 3.26. Lastly, number 3. So x bar, which is 2.75, and this one we have is 0.4. Assuming that the university has a total of 10,000 students, determine the number of students having a grade point aggregate of 3.7 or higher. And 3.7 or higher. Now 3.7 is on this side, So x1 is 3.75. Sorry, 70. So Z is x1 minus x bar over standard deviation. X1 is 3.7 minus 2.75. Standard deviation is 0.4. So we want higher than. Sorry? You Z should always be into 2 decimal places. 2.38. Now we read it from the table, not inside the table, from the table. This is Z. So we want the probability. Zero point 13. Now this is the probability, but that's the probability between 3.7 and 2.7. This. But what we need, higher than. So if you want higher than, or 3.7 and higher than, so this is what we need. So to get that, you will take 0.5. You eliminate this probability of 0.4913, and you get 0.00. Is that 83? Is that 00 or 083? 83, but we don't need a probability. We need the number of students. This university has how many students? 10,000. So on average, how many will attain a grade point of 3.7 or higher? Sorry? This was 83 or 87? Yeah, so 87 students. Good. Can copy. And I think with that, now for probability, you are somewhere, as well as for hypothesis testing. So that marks the end.